Okay, so we've been talking about dosage calculations, and we've only got a couple of things left to talk about. And I think I'd mentioned last week this is going to put our Unit 3 test next week on Monday. So that'll be April 9th. Will be our Unit 3 test. So in our dosage calculations, we've talked a lot about dilutions. We're not going to go back to those yet today. But those were kind of the basis for how our solutions are created for our dosages for medications. We talked about our dosage calculation formula. And we saw how awkward that was, where we had our doctor's orders divided by some on-hand dose times a vehicle gave us what we're going to administer to the patient. And we worked through, we saw how that we could use our dimensional analysis to do basically the same calculation. And we did a proportion method, but we're not going to go back to that. I want to just show you how dimensional analysis is really related to this dosage calculation formula. And the way I'm going to do it is I'm going to take this dosage calculation formula here and I'm going to rearrange it a little bit. Instead of D over H times V, I'm going to write it as D over 1 times V over H. So if we look at an example, let's say we have an order for Keflex 400 milligrams by mouth every 8 hours. So then it is constituted in a suspension. Our label for the Keflex is in an oral suspension of 500 milligrams per 5 milliliters. Now you might be wondering, kind of a side note, why do we have these odd concentrations like this? Why don't they just write that as 100 milligrams per 1 milliliter? Well, normally because the 5 milliliters is the capacity of the whole vial. So a whole vial of medication contains 500 milligrams. So that's what's printed on the label. Okay, so from here then, to find how much we're going to administer to the patient, we take the doctor's orders. Remember, with dimensional analysis, we always start with the doctor's orders. And all we really want out of there is the 400 milligrams. We put that over 1. Now, the on-hand dose would be the 500 milligrams here. On our dimensional analysis, we're getting rid of milligrams. That means we're going to put milligrams on bottom. And the vehicle that carries that to the patient is that 5 milliliters of fluid. You'll notice up here, on-hand dose and vehicle were filled in. This is basically our dosage calculation formula. We've just rearranged it a little bit, and rather than memorizing the formula, we're yet letting the units in the dimensional analysis tell us what to do. So the milligrams cancel out. We have 400 times 5 milliliters is 2,000 milliliters over 500, which comes out to be 4 milliliters of fluid of that suspension of Keflex to be administered to our patient. Now I haven't given you guys a lot of examples to try on your own so far. So one of my purposes today is I want to do some of those examples. So let me give you some examples, and I'm going to put a little bit more of the medical abbreviations in here just to give you some practice picking it out. If you were to actually go on to either our medical assistant or paramedic or registered nursing program, you would have, these are actually problems that appeared on an old version of one of the dosage calculation tests. So in your notes, I'm going to give you a minute or so to try this. The doctor orders digoxin of 500 micrograms orally once a day. The label in the bottle says 100 tablets, 0.5 milligrams per tablet. I'm going to have you try this one on your own. Note there's a difference. This is in micrograms, and this is in milligrams, so make sure you account for that. I'm going to give you about 1 minute here to try that in your notes, and then we'll go over it and see how you did. So let's see how we did here. So we're starting out with that order of 500 micrograms. Now you may have just moved the decimal point and did that conversion as you wrote it down, which I often do with my metric units. Or notice we have to convert that to milligrams. We're getting rid of micrograms to put micrograms on bottom and milligrams on top. Now the larger unit is the milligram. 1 milligram is 1,000 micrograms. Now we can do the conversion to tablets. Milligrams we're getting rid of, we're going to go on bottom. We have 0.5 milligrams per 1 tablet. So if we multiply this out, we've got 500 times 1 times 1 tablet. It's 500 tablets on top. On bottom, 1 times 1,000 times 0.5, the milligrams are divided out. So that's 500 on bottom, which comes out to be 1 tablet. Anybody have any questions on that one? Okay, let's take a look at another one. Let's say we have a doctor's order for 100,000 units of Ventolin, intermuscular. Let's say our label is, we have a 2 milliliter vial with 50,000 units per milliliter. So now we have those units there. That unit is just another way of measuring medication. Obviously, a unit's very small if we're looking at 50,000 units per milliliter. So here we're going to start out with our doctor's order again, 100,000 units. We use a capital U to abbreviate units. And we want to get rid of units. Down here, the 2 milliliter vial is not telling us anything as far as our conversion. That's telling us the size of the vial. Our equivalency is right here, 50,000 units per milliliter. So that means 50,000 units is equivalent to 1 milliliter. So the units cancel out, and this is going to be milliliters for us. So 100,000 times 1 milliliter is 100,000 milliliters. 1 over 50,000 is 50,000, which comes out to be 2 milliliters. So that is our basics of dosage calculations. The next step we did was we talked about IV flow rates. So I'm going to give you guys a couple of examples of those to try. So let's say that we have an order for 5,000 milliliters with 50,000 units of heparin to infuse at 750 units per hour. Let's say on our label, we've got a drop factor of 12 drops per milliliter. Now, just for the record, by the way, units are not something we will use on the exam itself, but you might end up with grains coming up or something like that. So you do need to be able to convert between strange units that we might run into. So for example, here, we've got 50,000 units, it's 5,000 milliliters with 50,000 units of heparin. That is actually an equivalency. That's saying 5,000 milliliters is equivalent to 50,000 units. So our order here is technically the 750 units per hour. That's 750 units for 1 hour. And we want to get this into drops per minute, is what we're requested to find. So we're going to have to change the hours, because I'll put that in there right away. 1 hour is 60 minutes. The hours are going to cancel out. We have to get rid of units. We're going to put units on bottom here. We have this equivalency. 50,000 units equals 5,000 milliliters. The units will cancel out. And I'm going to do this just to make my calculation easier. I'm going to divide both of those by 1,000. Make it 5 and 50. And now I still have to convert from milliliters to drops. So I'll put milliliters on bottom to get rid of the milliliters. And the 12 drops per milliliter means 1 milliliter is equivalent to 12 drops. So the milliliters have canceled out, and now I do have drops on top and minutes on bottom. If I look at my required solution, I do want drops on top and minutes on bottom. So on top, let's go ahead and multiply. 750 times 1 times 5 times 12. Giving us 45,000. The only unit on top is the drops. And on bottom, we've got 1 times 60 times 50, which is 3,000. That's in minutes as my units on bottom. That divides out to give us 15 drops per minute. So we're working with some strange units, but that's just fine. It still works out. So let's give you guys one to try on your own here. We're going to give you an order to infuse, and we're going to go back to our standard units of milligrams here. Our order is going to be to infuse 800 milligrams over 2 hours. Looking at our label tells us that this is concentrated as 25 milligrams in 8 milliliters and a drop factor of 18 drops per milliliter. So again, I'm going to give you guys a minute and let you try to figure that one out. Then probably should have told you that we're looking for drops per minute here. Hopefully you assume that. Let's take a look and see what our calculation looks like. So we have that order. 800 milligrams in 2 hours. I'm going to go ahead and get rid of the hours first because we need to get to minutes. Hours on top, 1 hour is 60 minutes. So the hours have canceled out. Need to get rid of milligrams. Milligrams will go on bottom since they're on top. 25 milligrams is 8 milliliters. So milligrams have canceled. Right now we've got milliliters per minute. We want drops per minute, so we're going to get rid of the drops, or rid of the milliliters, I should say. So put milliliters on bottom, 18 drops per 1 milliliter, so 1 milliliter is 18 drops, and the milliliters are gone. So now I'm going to just cancel 1 0 here with the 60 and the 80. So we've got 80 times 1 times 8 is 640 times 18. I will multiply that out. We get 11,520 drops. On bottom, we got 2 times 6 times 12, or times 25. 2 times 6 is 12, times 25 is 300 minutes, giving us 38.4 drops per minute. And for our purposes, we are going to leave, whenever we do an IV flow rate, the drops will always be rounded to 1 decimal place. So we would leave that as 38.4. We moved on then, dosages by weight. Dosages by weight, remember, we might have a range. So let's say that we have a label that says 18 to 20 milligrams per kilogram every 8 hours. You might have a patient that weighs 82 kilograms, or sorry, 82 pounds. And additional information on our label might say that this is concentrated at 50 milligrams in 12 milliliters. So let's figure out what would be the safe range to administer to the patient. Well, we look at our patient, first of all, is 82 pounds. This is in kilograms, so we have to convert. So that quick conversion is just dividing the pounds by 2.2. So we have 37.3, we're going to call it, kilograms. So we're going to start off with that weight. So 37.3 kilograms over 1. And our conversion here is kilograms. 1 kilogram is equivalent. Now we have to pick either the minimum or the maximum. We're going to use the maximum, 20 milligrams per kilogram for now. So the kilograms cancel out. We're now in milligrams. We need to keep track that is per 8 hours. We'll have to make sure we include that in our final dosage. But now we're going to convert that into milliliters with our 50 milligrams, equivalent to 12 milliliters. Now the milligrams have canceled out. So now we will go ahead and multiply that out. 37.3 times 20 times 12 is 8952, 8,952. On top, our only units right now are milliliters. On bottom, 1 times 1 times 50 is 50. There's no units, so we divide by 50. Gives 179.04 milliliters. So that would be on the high end of what we would administer. And that is, of course, every 8 hours. We've got to remember that time parameter there. What would be our low end then using the 18? Well, we could perform a titration. Taking that 174.04 times 18/20ths. We could also have done it in a proportion if we wanted to. Is 161.14, we're going to round that. milliliters. That is also over the 8-hour period. So basically, I would say 160 to 180 milliliters every 8 hours for that patient. I'm going to have you guys try one and see how these work for you. So let's say our label suggests that we use 4.5 to 5 milligrams per kilogram per hour. We have a patient that's 88 pounds. Also on the label, we have a concentration of 15 milligrams in 4 milliliters. So find how many milliliters we'd administer to that patient. Again, I'll give you guys a minute or so to try that. Looks like several of you are done, so let's take a look at this. So first of all, we take our 88 pounds, we divide by 2.2 to make it kilograms. So we get that our patient is 40 kilograms. Now we're going to use the maximum again, the 5 milligrams per kilogram. So kilograms go on bottom so they cancel out. 5 milligrams per 1 kilogram. The kilograms will cancel. Next, we want to turn our milligrams into milliliters using 15 milligrams. Now, milligrams are going to go on bottom in 4 milliliters. So the milligrams have canceled. Let's go ahead and multiply that out. We've got 40 times 5 is 200 times 4 is 800 milliliters. Over 1 times 1 times 15 is 15. We're going to 800 milliliters divided by 15. It's going to give us 53.33. Oops, it went down. Thanks for letting me know. We've been having an issue with that lately, so yeah, don't be afraid to yell out if she drops off on us. So yeah, 53.33 milliliters. And now remember, we do have that time of per hour. Now we want to do a titration. That's the maximum. So to find the minimum, we'll do that 53.33 times the 4.5 over 5. That's just the ratio of minimum to maximum. So notice I've left it in my calculator. I didn't clear out that 53.333, so I've got that full decimal without being rounded in there. So times 4.5 divided by 5, we get 48 is our minimum. So anywhere from 48 to 53.33 milliliters per hour. Any questions on those? Okay. Why is it so important that you guys know how to do these calculations? Well, because you are the last line before the medication hits the patient. If you're working as an RN, you actually are required to double check those calculations, those dosages, before administering to a patient. So you may end up with a doctor who gives you an order of 40 milliliters every 6 hours. For a patient that's 77 pounds. And when you look at the label might say 6 to 8 milligrams per kilogram every 8 hours. And 25 milligrams in 4 milliliters. You need to verify that the doctor's order is a safe dose. So first of all, we start out with the 77 pounds. Here we're going to divide by 2.2. The decimal didn't show up real well there. Let's try that again. 2.2 gives us 35 pounds is our patient. So let's start with that. 35 pounds. Now, note that this is for 8 hours. That's going to be very important because we notice the doctor's orders are over 6 hours. So we're going to have to account for that at some point in our calculation. But for now, we're going to ignore the time and just use the milligrams per kilogram. I don't know why I put 35 pounds there, 35 kilograms. Sorry about that. So now we're going to get rid of the kilograms. For every kilogram, we're going to use the maximum. Let's go 8 milligrams per 1 kilogram. So our kilograms cancel out. And then we're going to convert that using the 25 milligrams in 4 milliliters. So the milligrams will cancel out. This is going to give us milliliters of medication. So we've got 35 times 8 times 4. And our only units up there is milliliters, so that's 1,120 milliliters. On bottom, we've just got 1 times 1 times 25. So we divide out that 25, giving us 44.8 milliliters. Now here's where it's important to remember our time. That is per 8 hours. Now we need to titrate this to count for the 6 hours. 44.8 is every 8 hours. How much would that be every 6 hours? So times 6 divided by 8 gives us 33.6 milliliters every 6 hours. Now that was the max dose. The minimum dose is going to be smaller than that. So that's telling us that the 40 milliliters every 6 hours is too much. That's going to be outside the range. We can complete this calculation to find the lower range using the 6 and 8 milligrams. The 6 and the 8 here were because of the change in hours, from 8 hours on the bottle to the 6 hours doctor's order. The 6 and 8 here are because minimum of 6 milligrams per kilogram, maximum of 8 milligrams per kilogram. So that gives us 25.2 milliliters every 6 hours. So the safe dose on a 6 hour span is 25.2 to 33.6 every 6 hours. So the doctor's orders has exceeded that safe dose. I'm going to have you guys double check one. So our order is going to be 5 milliliters twice a day, twice daily. For a patient who weighs 88 pounds. We look at our label on our bottle, it's telling us there should be 250 to 300 micrograms per kilogram per hour. And there's 5 milligrams in 2 milliliters. So I want you to check to see if this is a safe dose. I'm going to give you a couple of minutes in your notes. Try to figure that out. I see many of you have stopped writing, so let's take a look and see how you've done. So we've got, first of all, we got the 88 pounds. We divide by 2.2 to get 40 kilograms. So we're working with a 40 kilogram patient. Getting rid of the kilograms, 1 kilogram. We're going to do the maximum again. You'll notice that's 300 micrograms. So the kilograms have canceled out, but we have micrograms that we're going to have to get rid of. And we're going to go ahead and do that right now. We're going to milligrams is what we need for our concentration here. So 1 milligram is 1,000 micrograms. Now, oops, we're going to get rid of our milligrams, go to milliliters right here. We've got 5 milligrams is equivalent to 2 milliliters. So the milligrams have canceled out, and we are now in milliliters. Now, I'm going to cancel out 3 zeros here and 1, 2, 3 zeros on top. make this easier on me. So I have 4 times 3 is 12, times 1 is 12, times 2 is 24 milliliters. 1 times 1 times 5 is 5. That divides out to be 4.8 milliliters. Remember our time here, that is per hour. This is twice a day. I'm to figure out twice a day, 24 hours in a day, divided by 2 is every 12 hours. So if this is 4.8 milliliters per hour, we need to know how much would that be over a 12-hour period. So we're going from 1 hour, so the 1 goes on bottom, to 12. So 4.8 times 12 is going to be 57.6 milliliters every 12 hours. Looking at our doctor's orders, 5 milliliters twice a day is way below that recommended dosage. Let's look at our lower end here. So that was using the maximum of 300. Let's look at what it would be for 250. So 57.6 times 250 divided by 300 would give us 48 milliliters every 12 hours. So I'm guessing there's a typo in this problem, that 4.8 milliliters per hour, well, they're only giving 5 milliliters every 12 hours. So it looks like somebody made a mistake here, because our safe range is 48 to 57.6 milliliters in that 12-hour span. So there's a dosage you would want to question. Okay, we've only got a few minutes left, so I'm going to leave it there. The next things we're going to do over the next couple of days, Wednesday and Friday, we're going to look at more of these safe doses. And then we're also going to look at dosages based on body surface area. And body surface area, a lot of times that's for burn victims and medications for skin conditions, eczema and stuff like that. So we're going to have to go over formulas and nomograms or charts that we can use for finding body surface area. And we will take a little bit of a look at safe dosages for those as well. So that is, like I said, next Monday, April 9th, is our Unit 3 exam. That leaves us with right around 5 weeks left, because we do lose the Friday in May there. Our last day is a graduation, so we don't have classes that day. And a lot of times what I like to do, I prefer to have our final exam, our last class will be on the 16th of May. I really prefer to have our final exam on the 14th, just to make sure we have time for me to grade them and get them back to you and for you guys to do corrections. So on that 16th of May, we'll most likely be doing some extra credit type problems, some calculations beyond what I would expect you to be able to do in the course. And I'll be answering any questions you have on your corrections to make sure you can get your corrections done and finished, so we can wrap up the semester on time. So anyway, have a great day. There is no new homework. This is still to finish up the homework that I gave you guys last Monday. All we did today was kind of review and recap all of it. So with that, I'll let you guys go. We'll see you on Wednesday. Have a great day.